and go through current slide. Okay, just in case Corey missed it at the end of last class, I started going over the fact that we have class today and Wednesday, and then y'all have Thanksgiving week off. We don't. We're back for one more week of class, and on Wednesday of that week after Thanksgiving, I'll give you the last test, which will cover as much as we get done in Chapter 4. If by chance, and there is a possibility, let me just see. I doubt if we'll get, because there's enough sections here that'll keep us going till the end of the term, I think. I was going to say there's a chance we could just touch on the next subject, but I don't think we will. I think basically variation of parameters will be about as far as we can go. All right. Now, so the Wednesday of the last class, I'll give you the test on Chapter 4. And if you'll have the next week to get it in. So what does that mean? That means on one hand, I'll need to have a few more research papers in. Okay? Got two from one person, last class and this one, with the other two missing them. Okay? And then I've got the first test from both classes, and the second test, I have one from this class, but none from the earlier class. Okay, so I'll need those in, preferably before I give you the final. That would be too much. Have both of those to finish in 1 week. So try to get the stuff in sooner rather than later. All right. Any questions? Okay. Now, where we left off last time, Chapter 4, higher order differential equations, 4.4, undetermined coefficients, the superposition approach, which is what we've been using. 4.5 is the annihilator approach, which goes over the same type problems, only it's a different way to do it. No reason to do them both. I chose to do superposition. It's closer to what we had done with everything else. And when I've taught it both ways, and it seems like students like it better, pick up on it faster than they did Annihilator. But they both are doing basically the same thing. So example 6 on page 147, we did example 5 last time. Now we're doing example 6. And it says determine the form of a particular solution of this. Okay, let me get my pen set up. Y double prime minus 9y prime plus 14y is equal to 3x squared minus 5 sine 2x plus 8x e to the 6th x. Okay, I hope I got it right. Okay. Now, determine the form of a particular solution. Notice they said a particular solution of this one. Now, even though just focusing on the right-hand side, I always like to at least try to convince myself about what the left-hand side will look like. Okay? What will be your complementary? Yeah, go ahead.
Squared minus 9m plus 14.
Okay?
M minus 7, M minus 2.
Okay?
M equals 7.
Okay? And then what kind of I always want to say characteristic, complementary solutions would they be? Would that produce?
Y equals
E to the what? That's it. E to the 7x and E to the 2x. Now, the only reason I did that is to make sure that this over here didn't have an E to the 7x or E to the 2x in it. It doesn't. Closest has E to the 6x, and that's not close enough. Okay? So, we don't have to worry about conflicts there. Okay? So, we can go back easily and complete that. They didn't tell us to, but I always like to do that just to make sure there's none that are similar on both sides. Okay, so all they say is determine the form of a particular solution of that. What would you suggest? YP, leave your undetermined coefficients in it. We don't have to determine these at this point. What would it be? AX squared plus BX plus C plus, okay, he doesn't follow the book's pattern, that's fine. D cosine, not 4x. Yeah. 2x E sine 2x what's that? F. Okay, now. Okay, F X plus G times E to the 6x. Is that what you said? Nicely done. Okay? If I understood your parentheses, were you? Yes, I thought I heard them in there. Okay. That's a G there. It's really ugly G. But that looks like it'll do it. Now, the book, of course, won't use a D. It uses an E here, an F here, and a G and an H there, but because it doesn't like to use capital D. Because you may confuse it with the operator. Yeah, right, I'm going to do that.
not this.
Not here. They don't fit here. Okay. And frankly, I think that's all they're looking for. Let's see. Okay. I don't know why they say the additional functions x and 1. Yeah, I guess you need to say a constant function, but yeah. And they, good. Now, what they did, which was perfectly fine too, and it's actually how I was going to do it, but then when I heard you saying it, I would have done this way. F sub x e to the 6x plus g e to the 6x. Which is exactly that without the parentheses. Okay, and well, but then they turn around and put it in at the end. I don't know. Either way will be fine. When they did the YP1 and YP2 and YP3, with this being YP1, those two being YP2, and they did that one as YP3, then they turned around at the end and did it like that. So either way is perfectly fine. Okay? Note that none of the 7 terms in that assumption for y sub p duplicates the complementary function, which is c1 e to the 2x plus c2 e to the 7x. They waited in to put that in. I like to do it the first. Okay. Now that was case 1. Those last 2 examples were case 1. And what was case 1? No function in the assumed particular solution is a solution of the associated homogeneous differential equation. Okay? We checked it. We made sure they weren't. Case 2 is, however, a function in the assumed particular solution is also a solution of the associated homogeneous or homogeneous differential equation. So it says the next example is similar to example 4, which is that one they said was a glitch, which I tried to warn you how to avoid the glitch. But anyway, here's example 7. Yeah, this I think will be pretty simple. Find a particular solution for y of y double prime minus 2y prime. Boy, that did a lot of good, didn't it? Plus y is equal to e to the x. All right. What's my recommendation of what you do first? Right. So y sub c. Okay, you're doing the auxiliary equation. Okay, that would be m squared minus 2m plus 1 equals 0. And what would that give you? And? Yeah. So it's m equal 1 and m equal 1. So what would be your complementary solution? C1. Second? Right, exactly. Plus C2 x e to the x. But guess what our right-hand side is? It's e to the x. That's what you can't use for your particular solution. E to the x. So what would be the next thing you would try? X e to the x. You can't use that one either. So the next thing you would try would be? Just keep going up. No, just keep going up. Well, yeah, it's going to have an a. Undetermined coefficient.
Like x squared?
That's it. That would be it. Your particular solution would then be y sub p would be a x squared e to the x. Okay. Now, you do not need the linear and constant term of this because you've already got them here. So it's just that. That's it. Does that kind of make sense? Right. You would think it would just be a e to the x, but that is basically the same as this. So no, not that. Well, then your next choice, as you said, would be a x e to the x. Well, no, that's the same as this basically. Just a rather than c2. So no, that won't work either. So just put up one more notch. X squared e to the x. Yep, that's it. So make it a x squared e to the x. Now, why does it do that and come back? I don't know. I think it's something to do with the power over here. I don't know. Okay. Now, all right. Now, in the last one, no. In the last two, they said determine the form of a particular solution. This one said find a particular solution. So we actually need to do this yet another few steps here. We stopped right there before. Now we actually want to find the particular solution, a particular solution. So what would you do? Take a derivative. Y sub p prime would be 2 ax e to the x plus let's put my a out front. A x squared e to the x, right? Product rule, right? Now, y sub p double prime would be what? You got two product rules. The first one would yield 2ax e to the x. Okay, I'll buy that. Plus what? 2a e to the x. Yeah, I'll buy that. That takes care of the first one. Now the second one. Now, happen to glance up above. The second one exactly like y sub p, so it'll be these two written down again, won't it? 2ax e to the x plus ax squared e to the x. Now let's combine some like terms here, and what do you get? Okay, yeah, now, just because my wife thinks I want everything to be symmetric, and I just sort of like it that way, let's just choose our x's. You want them increasing or decreasing in power? Decreasing. So let's start with the ax squared e to the x. Now, what you were going to say, plus 4 ax e to the x all right, we got it. Now that we got our y double prime and our y prime, let's plug into the original equation. It's going to take some room, and I'm not sure I'll have a lot of room. Let me try it down here. So that's ax squared e to the x plus 4ax e to the x plus 2a e to the x minus 2 times y prime. Well, there's our y prime. That's going to be minus 4ax e to the x minus 2ax squared e to the x. I didn't put those in the order you suggested. Sorry about that. We can live with it. Okay? And then the y is just plus ax squared e to the x. And supposedly that all is equal to e to the x. Where would you like to begin? Okay, here's a 4ax e to the x and a minus 4ax e to the x. Very good. That one and those two, you got 2ax squared e to the x minus 2ax squared e to the x. Those go away, and that leaves us 2a is equal to what? No, just 1. I left off the e to the x in it. Okay, I just looked at the coefficients. 2a has to be equal to 1, right? Okay, so that implies that 1/2. So now we can go up here and say a particular solution would be y sub p is equal to 1/2 x squared e to the x. And that doesn't bother at all with your complementary solution at all. So our general solution, I'll take it one more step, y is equal to c1 e to the x plus c2 x e to the x plus 1/2 x squared e to the x. Done. They didn't go that far, but I did. All right. Now, a little verbiage after the brown square that indicated the end of the problem, which ended with this thing right here, okay, in blueprint, okay. Just below that, suppose again that g of x consists of m terms of the kind given in table 4.4.1, which I noticed was one of your best friends, okay, and it should be. And suppose further that the usual assumption of a particular solution to be the superposition of all your particular solutions, okay, where y sub p sub I equal 1 to n are the trial particular solutions, solution forms corresponding to those various m y sub p's, right, whatever. Under the circumstances described in case 2, we can make up the following general rule. Do I need to write this down, or y'all got it? Okay. I hope that, Corey, you have it too. If any y sub p, I, those particular solutions you identify, contains terms that duplicate terms in your complementary solution, y sub c, then that y sub pi must be multiplied by x to the n, where n is the smallest positive integer that eliminates the duplication, which is what we did last time when we had e to the x and an x e to the x. We went on and did an x squared e to the x, just like we did before. Okay, let's go to example 8. Anyone need this any longer? You all right? Okay. Solve this. Y double prime plus y equal 4x plus 10 sine x. Ooh, and this is an initial value problem. Given that y of pi is equal to 0, and y prime of pi is equal to 2. Now, is that a legitimate initial value problem? Okay. It's a second order differential equation, so you need 2 conditions. You got those. Check. Okay? The 2 conditions must be evaluated at the same value. Pi and pi, check, check. Okay? So yes, that does fit the bill. All right. Where would you begin?
Well, I mean, you can do complementary.
And what would it be? Except, let's call it auxiliary. Okay. What's that? M squared plus what? Plus 1 is equal to 0. Because the auxiliary is the homogeneous part, which assumes that the left-hand side is equal to 0. So that's where the 0 comes from. What does this give you? If you put a plus 1 in here, you get 1 plus 1 is 2. That's not 0. And if you put a minus 1 in there, minus 1 squared is 1 plus 1 is 2, which is not 0. And which one will it be? Did you say I? Yeah, which is just I, plus or minus I. Because, like you just said, if I is square root of minus 1, I squared would be minus 1. Minus 1 plus 1 is 0. And minus I squared would be a minus times minus is plus. I squared is minus 1, and that would also be. So those are our two. What does that give you then? Y sub c, complementary here. C1. Second? No e's on this. Yes, that's it. Cosine. Not I. You do away with the i's. You always formula tells you can. X. Cosine x plus C2 sine x. Okay. Now we may reach a little bit of a dilemma here. Do we plug those values into the complementary solution, which only pertains to the homogeneous left-hand side, which isn't our whole equation here, or do we wait and plug them into the full general solution?
Why would we wait? If we can go ahead and get like an idea of what the problem might be.
Yeah. Well, one is that says y of pi is equal to that. It doesn't say yc of prime is equal to that.
Yeah.
So I think we have to go and do the whole shebang and then come back. Hey, what you got? I'm sorry? So let me check and make sure what I'm telling you is right. I believe it is. So we need to proceed with our y sub p's now. What would you suggest the y sub p to be? It's what?
AX plus B.
Okay, ax plus b would be a good way to start it.
Plus 10 cosine.
Okay, you don't need a 10 in there.
Sorry.
Yeah. Okay. See what?
Cosine.
Oh, but isn't that awfully close to what we have down here? Oh, yes. I agree with the C, capital C this time.
Go back to stepping up in this case.
Say again?
Are you stepping up in this case?
Yes, you do.
Like,
X. Is that what you said? Yeah, say yes. Yeah, okay. Okay. See, X cosine X plus, I knew you'd say that, D X sine X. And that should do it for us, shouldn't it? Okay? Now, again, because these, what would appear to be your YP duplicates one of those. So again, just like the little multiplication rule for case 2, if any y sub p, I, contains terms that duplicate in y sub c, then the y sub pi must be multiplied by x to the n, where n is the smallest positive integer that eliminates the duplication. And 1 would do it here. Okay, so what do you do with that y sub p now that you have it? Y sub p prime would be A plus second. Oh, okay. All right, you're going to do the minus first. That's perfectly fine. Minus C. I'll buy that so far. See what? X. That's sine x. The other half of that one, plus c cosine x. That's an ugly cosine. Okay, cosine. Ugly as cosine. Let me write it again. Goodness gracious. Okay, cosine x. Next, plus d x cosine x plus d sine x. Okay. Where do we go from there? Yep, y double prime, y sub p double prime would be negative c x cosine x, I'll buy that one, minus c sine x, okay, minus c sine x again.
I got confused. I was like, did I just do the next?
All right. Minus d x sine x plus okay, d cosine x oh really? Cosine x. Okay. I think we got them all in on one line. Barely. So now let's put them all together. The y double prime. Let's see if we can combine anything first. Of course, these two combine to be minus 2, and these two combine to be plus 2. Okay? All right. So let's see what we got. Y double prime then. Do you mind if I start with the positives? Okay. And the only positive I see is the 2d cosine x. Alright. Now, you want to do decreasing order of your x's, like we did last time? Minus cx cosine x minus dx sine x, and then we had minus 2c sine x, because those two went to 1. Okay? Okay, I think I got them all. Now we got plus y, no y primes in it, so that is plus ax plus b plus cx cosine x, yuck, plus dx sine x. That's supposed to equal, for x, if I can read my writing, plus 10 sine x. Okay, so let's see what becomes what.
So do you want to do the initial values?
Not yet. Let's combine like terms and get it as simple as possible. In all that mess, I'd go crazy. So let's see what we can do.
Well, the last two, cx cosine x and dx sine x. Knock out the...
Okay, I see what you mean. Here's a minus cx cosine x, there's a plus cx cosine x. Here's a minus dx sine x, there's a plus dx sine x. Very good. See, if you'd have been plugging in now, had been 4 terms, that would have been totally meaningless.
Yeah.
Okay. Okay, next. Here you have a cosine, there you have a sine, here you have an x, and there you have a b. So, there are no cosines on the right-hand side, so obviously 2d has to be 0. Would you agree? Okay, so that implies that d is equal to 0. Okay, I got to get it back. Okay, now, so that one's taken care of. This says that minus 2c has to equal 10, which would imply that c is equal to negative 5. Good. So that one's gone. And then you have ax here. So a must equal 4. So that one's done. And guess what b is? B is equal to 0. Okay. Now let's go and put your, you want to go back and put it in your particular solution, or you want to just go straight to general? Okay, so let's do the general. Y is equal to C1 cosine x plus C2 sine x plus 4x. That was your A was 4. Okay, sorry, my pen is so slow, I wrote on top of it almost. B was 0, so that's out of there. And C is minus 5, so that'd be minus 5x cosine x, and D was 0. All right, there is our general solution. Now we know that y of pi is equal to 0. Okay, so let's figure out what y of pi is. When pi is 0, cosine is negative 1. So that would be a negative C1. And when y is 0, sine is, when x is pi, sine would be 0. Plus 4 pi, right? Minus 5 pi, and cosine pi is, so that'd be plus 5 pi. So it looks like to me that little c1 must equal, and that's equal to 0. I'm sorry, I didn't put my equality in there. Is equal to 0. So if you move the c1 to the other side, you get c1 is equal to 9 pi. Don't you? Okay. Well, yeah, we just did all these across, and then that is equal to 0. So I'm going to move this to the other side. I'm really lazy. Okay. Right. All right. And then we still got to get the C2 part. So now we do need at least part. Well, no, we don't. We need to, with that being our y, we need to calculate what y prime is. And what will that be? Negative C1 sine x. My pen is really slow. C2 cosine x. Wait. Plus 4. yeah. 4x, right? No, I'm sorry. We're taking a derivative. My screen kept disappearing on me. I got lost what I was doing. Okay. Plus 4, okay. And then what?
Plus 5x.
Plus 5x sine x minus 5 cosine x. Okay, let me see if I can clean that up a little bit. All right, that helped. Okay, and that should be equal to 2, if I'm not mistaken. Yeah, y, okay, when I plug in pi. So y prime of pi is going to be 2, and that's going to be, all right, sine of pi is 0. Okay, minus C2 plus 4. That will be 0 minus or plus, plus 5. All right. Now I'm going to move my C2 to the other side, making it plus. That's subtracting the 2 from this side, making it C2 is equal to 7, I think. Is that what you got? Okay, so let's go back and plug into our general equation, which is this one here, and this is equal to, all right, C1 was 9 pi, right? So that would be 9 pi cosine x plus 7 sine x plus 4x minus 5x cosine x. There, I hope, is our general solution. Let's see if we can find it down here. Okay. Now, oh wait, I'm looking at the wrong place. Here we go. Y is equal to 9 pi cosine x plus 7 sine x plus 4x minus 5x cosine x done. Very good. Nicely done. Any questions on that? Is that making sense? All right. So let's move on to example 9. And remind me, we're going to 325, right? Okay. All right. Example 9. Solve this. Y double prime minus 6 y prime plus 9y is equal to 6x squared plus 2 minus 12 e to the 3x. Okay. Where would you begin? Okay. And what would it be? Say that a little louder. Okay. Okay, he's already got that. It's m squared minus 6m plus 9 is equal to 0, which is m is equal to minus 3 and minus 3. Okay? M is equal to plus 3 and plus 3. Right? Right. M minus 3 is equal to 0 squared. Okay? So what would that give you as a complementary solution? Y sub c is equal to c1 e to the 3x Yep. Plus
C1 X.
C
C2X.
e to the 3x. Okay. That takes care of our complementary solution. Now, this is not a boundary value problem. So what do we do for our particular solution? I sub p would be equal to, suggested anyway, ax squared plus bx plus c plus d. Okay, now there's if you're tempted to put e to the 3x, that's a legitimate temptation, except notice you can't because of that. So then your next suggestion would be dx e to the 3x, but that's taken care of too. So your next suggestion would be dx squared. That's done. Okay. That's your y sub p. My knee just popped. I hate it when it does happen. All right. And now what do we do? Okay. Y sub p prime is equal to 2ax plus b I'll put a plus, okay? Okay, I'll put a dx squared e to the 3x, 3 in front, got it? Next. Plus 2dx e to the 3x. Okay. I think that's all we can do on y sub p prime. So now we move to y sub p double prime. What would that be? 2a nine d x squared e to the 3x. Whoa, where'd you get that? What's that? And what's the first? Okay. Oh, I'm sorry. Okay, I got what you're doing now. Okay, I'd go on to the next one. So yeah, you're doing 6 dx e to the 3x. Okay, got it? Plus a little louder. 6d x e to the 3x. Is that what I heard? Is that right? Is that what you said?
Well, I meant to say, yeah.
Oh, I see.
The
Okay.
last problem down wrong, so I was like, I don't know why I'm doing this wrong.
We have one more term, don't we? Plus 2d e to the 3x. Okay, on this one, let's see if we can combine any like terms. I'm not sure we can, but let's see. Yes, there are some. There's one. So the 2a stays 2a. And the 9 dx squared e to the 3x stays as it is. But then you got 2 6d x e to the 3x, so that would make plus 12 dx e to the 3x, right? Plus 2 d e to the 3x. All right. I think we got that as simple as we can. So now we proceed with that. Now that we know what y double prime is. All right. Boy, all this coughing, my throat is as raw as it can be. All right, y double prime would be 2a plus 9d x squared e to the 3x plus 12 dx e to the 3x plus 2 d e to the 3x minus 6 times y prime. So please help me on this one. It's minus 12 ax, right, minus 6b, right, minus 18 dx squared e to the 3x minus 12 d e, ooh, I'm on the wrong one, dx e to the 3x. Yeah, get back here. E to the 3x. Okay? Well, that just gets to that. Now we got plus 9y, which would be, I'm just going to write it over here, plus 9ax squared plus 9bx plus 9c plus 9dx squared e to the 3x. I hope. That's a D. It's a pretty ugly looking D, but that's a D. Okay? And supposedly, that's equal to our all right, make sure that's equal to the right hand side here, which is 6x squared plus 2 minus 12 e to the 3x. Yuck. All right. Ooh, goodness gracious, how many terms, how many coefficients. Let's start with the constants. So we start with that. Here we have 2a minus 6b plus 9c. Agreed? On the left-hand side, 2a plus or minus 6b plus 9c is equal to 2. Got it? Okay. I'm going to cross out just so I won't panic later. Okay. Now, let's do our x squared e to the x terms. On the left, you have a 9d. I'm going to go and cross that one out. Minus 18d, right? And another 9d, and that all adds a 0 anyway, doesn't it? So it doesn't tell us anything about D. That just goes to 0, which was a very good thing to happen. Okay? Let me make sure. Yeah, I wiped out that one too. All right, let's go to our x e to the 3x terms. Here we got a plus 12 d e to the 3x and a minus 12 dx e to the 3x. And they wipe each other out. Good. Now let's do our e to the 3x terms. And that gives us here a 2d and that's it, isn't it? 2d on this side is equal to a minus 12 on that side. Am I seeing it right? Okay. So what would that imply? D is equal to negative 6, which, okay, doesn't help a lot there, but it's doable. Okay. Now let's go to our linear terms. Here we have a minus 12a right, plus 9a, that would be minus 3a. That's all I see. So minus 3a is equal to 0, right? Agreed or not? Did I miss any? Oh, it's not equal to 0, it's equal to 6. I'm sorry.
Yeah, one of those is x squared and one of those is 4a.
Oh, you're right, you're right, you're right, you're right, you're right. Let's go back and erase that one too. Okay, I started off doing linear terms and then I passed into square terms without realizing it. Okay, linear terms, going back and starting over, is minus 12a. Now I'll wipe that one out again. And here's a plus 9b. And that's equal to 0. Is that right? Because we have no linear term on the right. Now what does that imply? That implies that b is equal to, or 9b is equal to 12a. So divide everything by 9, and you get b is equal to 4/3 a. Or a is equal to 3/4 b. I don't know which would be better. So let's leave that alone for now. Now get to the x squared terms, which I think is the last term we've got. And it's 9a is equal to 6. Yay or nay? Yay, okay. Divide both sides by 9, and we get a is equal to 2/3. Okay, plug that in here, you get b is equal to 4/3 times 2/3, which, no, is that right? Yeah, that'd be 8/9. Ew, this is ugly, isn't it? Wait, I'm on the wrong problem. Yeah, we're okay. Whew. All right. Now,
I'm doing the same thing then.
yeah. Now this one is 2 times 2/3 from that first equation we have, right? 2 times 2/3 minus 6 times 8/9 right, plus 9c is equal to 2. Agreed? Because we sure don't know what c is. So this will be 4/3 minus, and 3 will go into that twice, so we'll go into that 3 times, minus 16/3 plus 9c is equal to, let me make that 27c, would that be 27/3 c? Would you be okay with that? Okay, plus 27/3 c, that's yes in Spanish, and that's equal to 6/3, which is 2, right? All right, wipe out your 3's, and you get 27c is equal to 6 plus 16 minus 4, which I think is going to be 22 minus what? It's 18? Is that right? So C is equal to 2/3. Yay or nay?
Yes.
Okay. All right.
That's all the ABs and Bs. That's easy.
The trouble is, it's all my room too. So what I'm going to do is come up here and erase all these things that I've marked out anyway. Oh, only it didn't start erasing. Okay, so we'll erase this patch in here. Even this down here, even though it's very necessary, but we don't need it. We got it up above too. Okay. So let's see what we got. Well, this is not a initial value problem, so we're going to keep. So our overall solution y is is equal to C1 e to the 3x plus C2 x e to the 3x plus, now our a up here is 2/3 x squared, b is 8/9 x, c is 2/3 again, plus 2/3, d was minus 6 x squared e to the 3x. I think. I hope. Let's see. Y is equal to C1 e to the 3x plus C2 x e to the 3x plus 2/3 x squared plus 8/9 x plus 2/3 minus 6 x squared e to the 3x. Done. All right.
It's a lot, but
Yeah, how do you eat a 5,000-pound elephant? One bite at a time. Yeah, just take it easy on it. Just do step by step by step by step by step by step by step. Yeah, until you get to the end. Okay. How are we doing on time? Do we have time to do example 10?
we've got 10 minutes.
10 minutes. Let's try it. I think. Yeah. It looks awfully short in the book, doesn't it?
Yes, so did the last one though.
Yeah. Well, this looks even shorter, so let's see what we can do. Ooh, that's a y triple prime. If my eyes are working. Y triple prime plus y double prime is equal to e to the x cosine x. Where would you begin? Goodness. I need to stand up and walk around something. These problems.
Can you even do an auxiliary equation?
Sure we can. What would it be?
It's just m to the fourth.
M cubed, isn't it?
That's right.
Okay.
Plus
No? Isn't that M y double prime?
oh, yeah, I'm sorry. You just threw me off.
Okay. And that's equal to 0. What would you do then? Okay. Whoa. Just real simple. Anyone remember the F word? Oh, yeah. What would that be? M squared times m plus 1 equals 0. What would that give you? M equals 0, and that's a double root, and -1, that's a single root. So now what would your complementary solution be? YC is equal to C1 to the, okay, how about that 0?
And then just C2?
No,
It would just be C.
huh?
Would it just be C?
It would just be C. It would be, well, okay, wait.
I was going to leave that one for...
Until the end.
Yeah.
You sneak. Okay. You were hoping we'd run out of time before we got to that. Okay. It would be C1 e to the 0x, right? E to the 0 is 1, so that would be C1. Okay? And that'll be okay. Well, how about the next one? Wait, don't even go there yet. This is a double root, remember?
Oh.
X equals 0, M is equal, huh?
Just
C2X. Raise it by 1. Okay, he's a poker player, so he knows to raise by 1. Yeah. Okay, and then the last one is C3. Got it. Okay, that's our, and you need, it's a third order. You need 3 independent coefficients. You got them. Okay. That was a little tricky. How about the other side? Y sub P would then be what?
So we got A.
A, I'll buy that one. E to the X. Anything else? Sine X is fine. Not like the book would do it, but it's okay. Plus B, e to the X, cosine X. Okay. Now, almost makes you want to go back and make sure you got your signs right, but I think we did. It's e to the minus X, that e to the X, no problem there. Okay? So I think we're all right. And besides, those have things multiplied by them anyway. Okay? So, where do we go from there? Yeah, y sub p prime would be Would that be a e to the x?
Yes, a e to the x cosine x.
Cosine x plus
Sine x.
a e to the x
Sine.
sine x. Okay, that's the first term.
Minus
Okay, minus is fine.
b e to the x.
If I can get my coughing under control. Minus b e to the x
Sine x.
sine x. What is wrong with this thing?
Plus b e to the x.
Plus b e to the x cosine x, right? I didn't hear it, but I figured you said it. Okay. Man. All right, let's do our y sub p double prime. I don't know if they do any good, but I've got to eat another one. My wife would be sending me to urgent care.
Yeah, you probably need to go before it turns into pneumonia.
Okay. What would be y double prime?
Well, yeah. Negative a e to the x.
Negative a e to the x sine x
Plus b e to the x.
wait, how about the a?
Or plus a e to the x.
Okay,
Cosine x.
okay. Okay, was that plus a? Cosine x, got it? Sine x, got it? Okay. I think we got them all there. Okay? Surely something here is going to combine. Let's look at these a's. Here's an a e to the x sine x minus and plus. So those disappear. And that leaves us 2 a e to the cosine x.
Now that last b e to the x cosine x, is that positive?
I believe it is. Okay? Yeah, the first three are negative. Okay. Now we get down here, and we've combined those two. Get down here. Here's a minus b e to the x cosine x and a plus e to b to x b e to x cosine x. Those go away, leaving you minus 2 b e to the x sine x. All right. There's your y double prime. That makes taking y triple prime a lot easier. I left off my x up here. Yeah, we got one more. Y triple prime, y sub p triple prime. Now I know we're out of time. Y'all need to go, or you want to finish it?
I can finish it. Start early.
What's that?
We can finish it.
Okay.
We'll just have to
We're not
start
too far. Mm-hmm. You're going to be at no extra charge. Y triple prime would be
is going to be two A e to the x and negative.
Okay,
Sin x
got it.
plus 2A e to the x cosine x
Okay, got it.
minus 2B e to the x cosine x minus 2B e to the x sin x.
All right. Now, I don't think anything there will combine. Okay, so now let's put all the king's horses and all the king's men here. So we're going to start with y triple prime. Yp triple prime is minus 2a e to the x sine x plus 2a e to the x cosine x minus 2b e to the x cosine x minus 2b e to the x sine x. That's your y triple prime. Y double prime just above it, and this is a plus 2a e to the x cosine x minus 2b e to the x sine x. And this is supposed to equal the right-hand side, which is e to the x cosine x. All right, let's see what we can do here. There was a sine x here, a sine x here, and there's a minus 2a e to the x sine x here. Nothing goes out there. So this is minus 2a e to the x sine x. Okay. There is no e to the x sine x, so this is equal to 0. So that implies that a is equal to 0. Do you buy that? If we did it right, I'm at the point now I may be missing things all over the place, but this is the only term with e to x sine a e to the x sine x. Okay, that's cosine, that's a b anyway, that's a sine, that's a e, but that's cosine, and that's a b. Okay. So I get that a has to be equal to 0 because there is no e to the x sine x over here. All right, so that one's out. Now I may be wrong. Make sure. What? Okay. So let's look at our e to the x cosine x's. A e to the x cosine x's. We have 2 here, and we have 2 here, making 4 of them. 4a e to the x cosine x should be equal to, well, wait, let's just leave those off. 4a is equal to 1, right? Got 2a here and 2a here. Okay, so that's 4a times e to the x cosine x. Now here, your e to the x cosine x is 1 up. So 4a is equal to 1. A is equal to 1/4, I hope. Wait a minute. Wait a minute. You can't wind up with a is equal to 0 and a is equal to 1/4. There's some problem here, folks. And neither one of them are right. We are doing 10, aren't we? I think I must have made an error somewhere here. Wait. Well, what we're calling A, they're calling B. But still it's wrong. Yeah, but there's none that comes out 1/4. And certainly you can't have 1 equals 0 and 1 equals 1/4 anyway. So there is an error somewhere in here. Now you want that to be your homework, to try to find the error here. Once I delete it, it's going to go. And I'm not about to go and check on it. So y'all are going to find where we dropped a plus or minus sign, or I did something wrong or something.
Well, if you did it wrong, it's because we said it wrong.
What's that?
Well, if you did it wrong, it's because we said it wrong.
Well, yeah, possibly. But I was trying to think as I went too, so obviously something went wrong. So if we need to, we'll start it over next time. It should go a lot easier. If not, if y'all figure out where it went wrong, we'll start with example 11. So I'm going to put either 10 or 11. Okay? And that's where we'll begin next time. Okay, this is a fairly long section. But we're almost at the end. I mean, we're right at the end. So homework exercises here. Do any of the odds 1 through 25 that may be in the back of the book. Do any of the odds 27 to 35 that may be in the back of the book. And they haven't done a boundary value problem. And they're not about to do a boundary value problem. So try to do either 37 or 39 if those are in the back of the book. And we haven't done the discontinuous one, and I don't think they're going to do a discontinuous one. But we'll hold off on that and worry about that tomorrow. All right, good deal. Sorry about botching up that last one, but it was getting foggier and foggier in my head. So. Okay.
I think I know what we did.
What is that?
Well, never mind. No,
Not yet. Okay. They skip so many steps in the book, I can't.
Yeah, it's hard. You can't check yourself in the book.
Right, and until you get to the very end, say, no, that's not what they got. Sort of wish I could hang on to that. Let's just see if what we got here is what they got. They put your e to the x cosine x's together, and they did them backwards, that's right. I don't know. That'll be harder to see, but anyway. I'm not going to worry about it. The head's not working well anyway.